We have to exercise දෙකේ උත්තර බලමු. Exercise 1 is regarding the small samples. Small samples. Exercise 1, the difference between two population means. Exercise 2 is regarding the testing hypothesis about population proportion. A particular company manufactures two brands of batteries which are used in aircrafts. The measures computed using the measures computed using details derived from 4 batteries from brand A and a sample of 5 batteries from brand B. Mean life is 18,750 with a standard deviation 500. Brand B mean is 18,480 with standard deviation 800 hours. Test whether the mean lifetime of these two brands of batteries is significant at 5%. Assume that the lifetime of batteries are normally distributed. Now, what is this case? Now, this is the normal populations. Assume that the lifetime of batteries are normally distributed. That means the two populations are normally distributed. Normal populations දෙකක්. So then, now this should be under case 1, 2 or 3. So cannot be case 4 or 5. ඉස්සෙල්ලා බලන්න if it is normally distributed නම් එක්ක case 1, එක්ක case 2, එක්ක case 3. And then what will happen? Now look at the standard deviation. Now check whether is it now from a then look at the size of sample. Both are small samples. They come small samples. The small samples they got now. So then we have to see whether it is from either case 1 or case 3. එතකොට case 2 එකක් දැන් අපිට අයින් කරන්න පුළුවන්. So then what is your case 1? Case 1 is for any size of sample. Case 3 is for small samples only. So now then how it goes as case 1? Case 1 වෙන්නේ. So if the population standard deviation is given. Now here population standard deviation is not given. Sample 1. Now this is under case 3. Now this is under case 3. Now you have to see whether the lifetimes of two batteries are significant or not. That means is there any difference between two lifetime of batteries or not. So how we make our hypothesis statements? Build up hypothesis statements. So then all difference between two means here mu1 is equal mu2. Always our h1 is, if not is equal mu2. Is there any significant difference between them? Mu1 is not equal mu2. Now your alternative hypothesis is mu1 is not equal mu2. So then type of test is two-tailed test. Now this is two-tailed test. T-distribution. Two-tailed test and T-distribution. Two-tailed test. T-distribution. Right. Now we have to find out the critical value. So how we get the critical value? What is the significance level given here? Significance level at 5% level of significance. 5% level of significance. එතකොට alpha over 2 අපි ගන්නෙ alpha නෙමෙයි alpha over 2 0.025. Alpha over 2 is 0.025. Alpha over 2, 0.025. What is degree of freedom? There are, once we are dealing with two samples, degree of freedom is given by N1 plus N2 minus 2. N1 is equal, sample, 4 batteries from brand A, 4 plus 5 minus 2. Degree of freedom is 7. Degree of freedom is 7. N1 plus N2 minus 2. Degree of freedom is 7. So then there are two critical regions. Critical regions දෙකක් තියෙනවා. On either side of distribution. Degree of freedom is 7. DF 7. 0.025 the critical regions. What are the key values? In the 0.025 critical region, මේකත් ඒකමයි 0.025. So then refer your key table at degree of freedom 7 and 0.025. The key table value. Key table value.
2.3646.
Key table value is 0.025 degree of freedom 7. 2.365. Is it correct? 2.365. Table value එක 2.365. හරිද? 2.365 is the table value.
2.3646 කියලා.
Sorry.
2.3646.
Yeah, that's okay. 2.36 කිව්වා 356 කිව්වා කමන්නේ. ඒක කමන්නේ. 2.36 2.356 356 කියන්නේ අතරම 2.36 තමයි. 2.36 කියලා ගන්නකො. 2.36 and minus 2.36. Right. Analyzing sample data. Now here you have large calculation. Analyzing sample data. Analyzing sample data. So now here you have the pool variance. Now just calculate what is pool variance. SP. Pool variance is S square P N1 minus 1 S1 square plus N2 minus 1 S2 square divided by N1 plus N2 minus 2. So then N1 is equal the 4 batteries from brand A. Brand A වලින් batteries 4යි අරන් තියෙන්නේ. 4 minus 1. What is the standard deviation is 500. 500 square. 500 square plus N2. 5 batteries from brand B. 5 minus 1. S2 square is 800 square. 800 square divided by 4 plus 5 minus 2. Pool variance is 3 into 500 square, 3 into 500 square plus 4 into 800 square over 7. ඒක පුළුවන් තරම් ඉක්මනට සුළු කරලා ගන්න square p. Three into 500 square. 750,000 plus 4 into 800 square. 2,560,000 divide by 7. Divide by 7. Pool variance is 2,560,000 divide by 7. That is 472,857. So then pool variance standard deviation is square root of this one. 472,857 square root of this. 470. $688. 688. Make a pool variance pool standard deviation 688. Make a 688. However, had we can make 688. Am I correct? 688. 688 is your pool standard deviation. Yes. Yes, right. It was අපි දැන් මේක මතක තියාගමු මම මේ ටික පොඩ්ඩක් මකනවා බෝඩ් එකේ. If you need to write this ඔන්න ලියාගන්න ටග්ගාල T value එක ගන්න ඉස්සෙල්ලා ඔන්න ලියාගන්න මේක කවුරු හරි උත්තරය ආව නැති කෙනෙක් ඉන්නවා නම් so just copying down this මකන්න ඉස්සෙල්ලා මම මොකද නැත්තම් මට බෝඩ් එකේ හිටියේ නෑ ඒකයි 688 is your pool standard deviation. හරිද? copying finish to copying down ලියාගෙන ඉවරද? ඊට පස්සේ අපි ගමු t table value එක t value T value 688. This is 688. Your T table value x bar 1 minus x bar 2. T value mu1 minus mu2 over SP square root 1 over n1 plus 1 over n2. X bar 1 carry for grand A. Grand A x bar 1 is given as 18,750. S1 is equal 500, S1 500, N1 is equal 4. Brand B is indicator 2, brand B, X bar 2 is equal 18,480, 18,480. S2 is equal 800, N2 is equal 5, N2 is equal 5, SP is equal 688, SP is equal 688. So your T value is equal X bar 1 minus X bar 2, 18,750 minus 18,480, mu1 minus mu2 is equal 0, mu1 minus mu2 is equal 0, divided by your pool standard deviation 688 square root 1 over 4 plus 1 over 5. 1 over 4 plus 1 over 5. So T value is equal, T is equal, numerator 18,750 minus 18,480, that is 270 on numerator, 270, denominator 688, 1 over 4 plus 1 over 5. So as a decimal, this is 0.25, this is 0.2, 0.2. T value is equal 270 over 688 into 688 into square root 0.45. Square root 0.45. 270 over 688 into square root 0.45. 0.67. 0.67. T is equal to 270 over 688 into 0.67. 460.96. 270 over 460.96. That is around 0.58. The T value is around 0.58 plus 0.58. මේක දාවේ T value එක 0.58. T value එක ඕක දාවේ 0.58. T value calculated T value is 0.58. ඔය උත්තරේ දාවේ. හැදුවේ නැද්ද ඒ ගාන? හැදුවා නේද ඔයගොල්ලෝ? 0.58 දාවේ. වැරදුන්නේ නැහැ නේ මට නේද? ඒක තමයි එන්නේ. 0.58 or 0.59. The value is around 0.58, 0.59. අන්න ඒ වගේ උත්තරයක් එන්නේ. ගාන හැදුවේ නැද්ද ඕගොල්ලෝ? ගානක් හදන්න කිව්වම හදන්න ඉපේ ගාන. හැදුවද? 0.59. 5859. What will happen? It's not lies into acceptance region. It's not accepted. It's not accepted. So what is your conclusion? So then we can say that mean lifetime of two brands of batteries is not significant at 5% level of significance. Lifetime of lifetime of brand A and brand two, brand A and brand B batteries are not significant at 5% level of pigment. This is your conclusion. They are not different. So then it's not accepted means V1 is equal to lifetime of brand A and brand B batteries are not significant at 5% level of significance. Now this is your final conclusion. මේ තමයි මේකේ conclusion එක. The lifetime of both the brands of batteries are not, so they are same. There is no any significant difference in between them. No any significant difference in between them. At but 5% level of significance. මේක ලියන්න ඕනේ. So this is at 5% level of significance. Now this is the answer for exercise 1. The difference between two means. Difference between two means. අනුපාඩුවක් තියනවා නම් හදාගන්න ගානේ. හදාගන්න අනුපාඩුවක් තියනවා නම් ගානේ. ඊට ඊළඟ එකට යන්න. Exercise number 2. ගාන හදාගන්න. ඊට පස්සේ ඊළඟ එකට යන්න. Next one. Exercise number 2. Exercise number 2. This is regarding population proportion. A producer claims that at least 35% of the proportion in an area prefer to buy the soap what produced by his company. According to the consumer survey of 100 people of the area, only 30% of them buy the soap which produced by the above mentioned company. Check producers claim at 1% level of significance. So then producer says that at least 35%. Again, see the 35 වැඩි ගාණක්. So then why is so? ඒ company හදන සමන් වර්ගයේ මිලදී ගන්නවා කියන. එතකොට so then H naught is equal mu is sorry phi is equal 0.35. Phi is equal 0.35. Exercise number 2. Exercise 2. So then at least 35%. At least 35% you are greater than 35 is value. So then what is your H1? Less than 0.35. Less than 0.35. The type of test, one tail test. Left tail category. Left tail category. Now there are no any options. It is normal distribution. Now this is normal distribution. Critical value, what is level of significance is 1%. 1% level of significance. Rejection region goes to the left stage of the distribution. 1% on left stage. Alpha is equal 0.01. 0.01. 1% goes to the left edge of a distribution. So this is 49% minus 2.33. Critical value minus 2.33. Analyzing sample data. Analyzing sample data. Analyzing sample data. Z is equal P minus 5 square root of that. So what is your P? 30 over 100. 0.3. 0.35. N is equal 100. Calculate your Z value. 0.3 minus 0.35 over square root 0.35, 0.65 over 100. Over 100. Point 30 minus 0.35. Minus 0.05 over divided by 100 square root of that 0.048. Z is equal 1.404 minus 1.04 minus 1.04 acceptance region. 2.33 is the boundary value. It's not accepted. It's not accepted means what will happen? The manufacturers claim, the producer claims, the producers claim. Producer's claim is true at 1% level of significance. Producer's claim is true at 1% level of significance. Conclusion. Producer's claim exercise number 2 answer. Exercise number 2 answer. ඔය උත්තරේ ආවද? Exercise 2 it's not accepted කියලා ආවද? What is answer? ඇහෙන්නෙත් නෑ ඔයගොල්ලෝ කියනවා වහිනවා හොඳටම. Yes, right. Now this is testing hypothesis about any mistake. I'll give you 2 minutes copying down them. And then the last part of this testing hypothesis is difference between two proportions. Now, difference between two population proportions. Okay, වැරද්දක් තියෙනවා නම් හදාගන්න. Right, now we move to the next one as difference between two population proportions. Testing hypothesis about difference between two population proportions. There are practical situations where the decisions should be made comparing the differences of proportions of the number of units with the particular attribute in two populations. Again, proportions දෙකක් සමානද? එහෙම නැත්නම් එකකට වඩා එකක් වැඩිද? එකකට වඩා එකක් අඩුද? One is greater than to another, one is less than to another, or the both proportions are equal, like mu1 and mu2. So 6% of the foreign articles in bag A are not redeemed, and 5% of foreign articles in bag B are not redeemed. Again, pass කරන බඩු වලින් 100ට බෑග් A එකේ 106ක් නිදහස් කරගන්නේ නැහැ, බෑග් B එකේ 105යි. එතකොට මේ නිදහස් කරගන්න proportion එක, are they equal to each other in both bags? One is greater than to the another, or one is less than to the another. අන්න ඒ වගේ එකක් තමයි අපි check කරන්නේ. Once both populations are given to be distributed normally, or when each sample size is sufficiently large, the hypotheses are phi1 is less than phi2, phi1 is greater than phi2, or not equal to phi2, vice versa to phi1 is equal to phi2. Make it same technique. Difference between two population means what is your H naught? Phi1 is equal phi2. So then, depending on the given question, sometimes phi1 is not equal to phi2. Again, samana than at that. Is there any significant difference? Or phi1 is greater than to the phi2. Or phi1 is less than to phi2. Same technique as difference between two population means. So then your null hypothesis is phi 1 is equal phi 2. හැම වෙලේම අපි ගන්නෙ phi 1 is equal phi 2 as our H naught. Depending on the given question, your alternative hypothesis is phi 1 is not equal phi 2, phi 1 is less than phi 2, or phi 1 is greater than phi 2. ඔය තුනෙන් එකක් තමයි එන්නේ. ඒක තමයි දාලා තියෙන්නේ. So how we construct the build up hypothesize statements. So now again no condition. මේකෙත් අපිට අර ඉස්සෙල්ලා වගේ case 1, case 2, case 3 මේ කිසිම දෙයක් නැහැ. So then what is our distribution? So testing hypothesis about difference between two population proportions. Testing hypothesis about difference between proportions. Right. What is your sampling distribution? P1 minus P2. The large sample from the condition is P1 minus P2 is normally distributed with phi 1 minus phi 2. What is the variance? Phi 1 minus phi 2. Variance is phi 1 into 1 minus phi 1 over n1 plus now this is your sampling distribution. Sampling distribution of sample proportions. Only one case is there for large samples. Extension of single proportion. So then what is the mean? Mean is equal phi 1 minus phi 2. What is the variance? Phi 1 into 1 minus phi 1 over n1 plus phi 2 into 1 minus phi 2 over n2. Now this is your variance. So the Z value. Now this one follows the normal distribution only. Z value is, so the denominator of the Z value is the square root of this one. Standard error. Make a square root. But here again, there is a small difference. One special case, like mu1 minus mu2, third case again, mu1 minus mu2. Now here there is a small difference is there. What is the Z value? Z value is not the denominator, is not the square root of this one. Make a vargamule. So now look at the Z value. Z is equal. So numerator is okay. P1 minus P2 minus phi 1 minus phi 2 divide by square root of P bar into 1 minus P bar into 1 minus P bar 1 over n1 plus 1 over n2. Again, one special case. Really, the square root of this part to be goes here. Make it square root according to their normal theory. But here even, like the third case of difference between two population means. So then what will happen? So then our T value is with the pool variance. Pool variance there is one special case is there. So what is that? The standard error is P bar into 1 minus P bar 1 over n1 plus 1 over n. What is this P bar? What is this P bar? P bar is like this. P bar P bar x1 plus x2 over n1 plus n2. So how we evaluate this one? Now here these questions always given that two sample proportions. So then that is P1 is equal 18 over 100 and P2 is equal 42 over 100. P2 is equal 42 over 100. So how we calculate our P bar? P bar is equal sum of two numerators. 80 plus 42, 100 plus 100. 100 plus 100. What is that? 80 plus 42 is 60. 60 over. This one 42 over 400. So then small mistake is there by me. So then first fraction is 18 over 100. Second fraction is 42 over 400. 400. So then I got a mistake. Sorry. 60 over 500. 60 over 500 is our P bar. 60 over 500 is our P bar. One special case. Another special case. Testing hypothesis about difference between two population proportions. Again, your Z value has one special case. Like mu1 minus mu2. Third case again. So then there is a value deal with full variance. Now here again a different value is there. That's the high and square root of this one come up to here. Now here there is a different one. So then the method of getting P bar. Right. By taking all together, now then we'll do one worked example to understand really what will happen. Really what will happen. In a particular company, there are two machines A and B. In a particular company, there are two machines A and B used for production. A sample of 1,000 drawn from machine A and sample of 500 drawn from machine B were examined. It is found that 250 items from machine A and 100 from machine B were defective. Defective proportions are there. So then, test the hypothesis that defective percentage of two machines are significant or not at 5% level of significance. එතකොට defective percentage එක machine දෙකෙන්ම හදන නිෂ්පාදන වල defective percentage එක සමානද නැද්ද? Now what is that? So then the check whether test the hypothesis that defective percentage of two machines are significant or not. Again, මේ machine දෙකෙන් හදන defective percentages the සමානද නැද්ද කියන එක තමයි අපි අහන්නේ. Right. Now we'll see one by one how to do that and how to get this special Z value. Another special case. Make a special cases දෙකක් තියෙනවා. So then case 3 of mu1 minus mu2 and now then difference between two proportions. Build up hypothesis statements. Build up hypothesis statements. First step. As usual, what is H naught? Phi 1 is equal phi 2. Here we make it H naught here. So now what about H1 according to your question? Are there any significant difference between the defective proportions of two machines? මේ machine දෙකේ නිෂ්පාදනය කරන දෙකේම දෝෂ ප්‍රතිශතය සමානද නැද්ද? So then significant or not? Not equal to 5. Type of test. Type of test. Two-tail test. Normal distribution, no any other options. Normal distribution. This one does not follow Seti distribution. Critical value. Critical value. critical value. What is your significance level? So then see whether at 5% level of significance. 5% level of significance. So now you need alpha over 2. Right. Now find your critical value. So then 0.025 on either side of the distribution. Rejection area. Zero to 5. This is 0.4750. So what is your Z where the critical value is plus 1.96 and minus 1.96. Right. Analyze your sample data. Analyzing sample data. Analyzing sample data. ඉස්සෙල්ලා අපි P bar එක evaluate කරමු. Evaluate P bar. Evaluate P bar. So what is your P bar? P bar is equal x1 plus x2 over your proportion 1, P1. Proportion 1 is out of the machine A is 1, machine A. A sample of 1,000 drawn from machine A. So then how many defectives are there? 250 items from machine A. 250 divided by out of 1,000. P2. You drawn 500. So then how many defectives are there? 100. 100 over 500. 100 over 500. Hariyan? Hundred from machine B were defective. Right. Now evaluate your P bar. X1 plus X2. 250 plus 100. Divide by P bar is equal 350 over 1,500. 1,500. What is this as a decimal? 350 over 0.23, 2 decimals. 0.23. Right. Now you already evaluate P bar. So what is your Z now? Now your Z is equal P1 minus P2 divided by square root 1 minus P bar 1 over 8, 1 plus 1 over 8. Now this is your Z value. 1 over 8, 1 plus 1 over 8. Right. So now your machine A is 1. Machine A P1 is 250 over 1,000. N1 is equal 1,000. N1 is equal 1,000. G. P2, now as a decimal here. P2 100 over 500. 100 over 500 then. 100 over 500. N2 is, that is 0.2. 0.2, N2 is 500. N2 is 500. Now calculate your Z value, calculate Z value. මම මේක මේක අතර දිනනවා. Z is equal P1 minus P2 P1 minus P2 again 0.25 minus 0.20 0.20 pi 1 minus pi 2 is 0 අරක වගේමයි pi 1 minus pi 2 is 0 denominator p bar කියන්නේ 0.23 0.77 1 over n1 1 over 1000 plus 1 over 500. So what is that? So then on your numerator 0.05, meaning 0.05 square root of 0.23, 0.77. What is this? 1 over 1000 plus 1 over 500 as decimals. Decimals are in the decimal. Point 0.001 plus 1 over 500. 0.002. 0.002. Right. So 0.05 divided by square root. 0.23, 0.77 and 0.003. मैं देखें एकत्र करको हम 0.003. Right. So what है? Z is equal 0.05 divided by bottom bracket 0.23 into 0.77 into 0.03003. Square root of that 0.023. Z is equal 0.05 divided by 0.023. 0.023. Point 0.05 divided by 0.023 is 2.17. 2.17. Z is equal to 2.17. So then, what is your rejected? No, 1.96 only pass rejected. H not rejected. H not rejected. H not lies into rejection area. H not rejected. H not rejected, can H1 accepted. So what is your conclusion? No any significant difference between defective percentage of two machines. So how you write your conclusion? defective percentage of two machines are significant at 5% level of significance. Again, මේ දෙක වෙනස්. එතකොට defective percentages of two machines are significant at 5% level of significance. ඒ වගේ ලියන්න your conclusion. ඒ කියන්නේ මේ දෙක වෙනස්. Defective proportion of both machines are not equal at 5% level of significance කියලා දාන්න. That is necessary. Now this is your proportion one. The testing hypothesis about difference between two proportions, some special case. එතරම් දෙනවා පොඩි special case එකක්. So by looking at them, complete the exercise. Two samples of housewives in the Matale district and Colombo district were drawn at random, and the details collected regarding the preference for a recently introduced confectionery meal are stated in following table. Data දීලා තියෙනවා Colombo district out of 500, 240 use that meal. මේ artificial meal එක කොළඹ district 500කින් 240ක් පාවිච්චි කරලා තියෙනවා. මාතලේ district 500 out of 1500 1500කින් 500ක් විතර වගේ තමයි මේක පාවිච්චි කරලා තියෙන්නේ. Test whether is there a greater demand for this meal in the Colombo district than that of Matale. ඒතර කොළඹ district එකේ මේක වැඩිද කියලා තමයි අපෙන් අහන්නේ. Proportion who use that meal is the greater than that of Matale district figure. ඒකට වඩා වැඩිද කියලා. So at 5% level of significance. ගාන හදාගන්න පුළුවන් වෙයිද? ওই ගාන හදාගන්න පුළුවන්ද? පන්තිය හදනවද? පුරුදු වෙන්න හදනවද පන්තියේ? විනාඩි 10ක් 15ක් දෙන්න හදන්න පොඩි උත්සාහයක් දාන්න. විනාඩි 10ක් විතර බලන්න try එකක් දෙන්න බලන්න මේක දිහා බලාගෙන හදන්න. pi 1 is greater than pi 2. කොළඹ district එක ගත්තොත් pi 1 කියලා. So then greater proportion than the මාතලේ district. එතන මේ ආහාර වර්ගයේ පාවිච්චි කරන proportion එක කොළඹ district එක වැඩි දානවා කලුතර sorry. ඒක දීලා තියෙන්නේ මොකද්ද? මාතලේ district. බලන්න මේක දිහා බලාගෙන hypothesis statements ටික අරගෙන critical value ඒ ටික කරන්න බලන්න. මම විනාඩි 10ක් විතර දෙන්න. පොඩි උත්සාහයක් දරන්න. උත්තරේ ආවද ඔයගලන්ට ගානේ? ගාන හැදුවද? හැදුවද ගාන? මොකක්ද දෙන්නේ? එක්සයිස් එකේ උත්තර බලමුද? Check the answers. The Colombo district, the proportion in Colombo district is greater than that of Matale district. එතකොට කොළඹ district එකේ proportion එක මාතලේට වඩා වැඩිද අඩුද කියන එක තමයි අපි හොයන්න යන්නේ මේකේ. Build up your hypothesis statements. Phi 1 is equal phi 2. So what is your H1 now? So then Colombo district කියන්නේ 1 කියලා ගත්තොත් phi 1 is greater than phi 2. Phi 1 is greater than phi 2. Type of test, one tail test, normal distribution, critical value, 5% significance level, alpha is equal 0.05. Right tail test එක 5% on right edge. එතකොට මෙතන 5% critical area මේක 45%, 1.64 or 1.65. Analyzing sample data. Evaluate P bar. ඉස්සෙල්ලා P bar බලමු. P bar. N1 plus N2. P1 කියලා ගමු කොළඹ district P1 මොකක්ද proportion එක 240 out of 500. P2 මාතලේ 600 out of 1500. P bar is equal 840 over 2000. Zero point four two. Z value P1 minus P2 by 2 divided by square root 1 over N1 plus 1 over N2. P1 කියන්නේ P1 240 over 500. මේක decimal එකක් විදියට කරගන්න. .48. N1 is 500. P2 600 over 1500. .4. $1,500. Z is equal 0.48 minus 0.40. 51 minus 5 you get y. 0.42 bar 0.58 1 over N1 1 over 500 plus 1 over 1500 0.08 0.42 0.58 as a decimal 0.002 plus 0.0006. Z is equal Z කියනවා 0.08 over 0.42, 0.58 අර දෙක එකතු කරපුවාම වෙනවා 0.002 plus 0.006 0.0026 Z is equal divide by square root 0.42 into 0.58 into 0.0026 මේ ටික අරගෙන මේකේ ස්ක්වයර් රූට් එකම ගන්න 0.025 0.08 divided by 0.025 3.2 Z is equal 3.2 rejection region. H0 lies into rejection region, H0 rejected. 1.65 වලින් පස්සේ H0 rejected. H0 rejected can H1 accepted. So then phi 1 is greater than phi 2. Phi 1 is greater than phi 2. එතකොට මේ කියන්නේ මොකක්ද? Greater demand for the meal. There is a great demand for the meal in Colombo district than that of Matale at 5% level of significance. Make my conclusion. The great demand for the meal in Colombo district than that of Matale. Colombo Matale වඩා මේ ආහාර ක්‍රමී සඳහා වැඩි ඉල්ලුමක් පවතිනවා at 5% level of significance. මෙන්න මේ වගේ තමයි මේක ගන්න ඕනේ. The calculations. One another special case. ඔය උත්තරේ ගත්තද කවුරු හරි? What is the answer? කාට හරි ආවද එතෙන්ට නිකන් හරියට උත්තරේ? Got it? උත්තරේ ගත්තද?
Yes, madam.
උත්තරේ ආවද?
Oh, madam.
The testing hypothesis about the 4 different situations: population mean, difference between two means, proportion and difference between two proportions. මේ ටික තමයි තියෙන්නේ. The types of questions. There are some special cases. මේකත් එක special case එකක්. So the difference between two proportions, difference between two means වලත් අපිට තිබුණා pool variance එක හොයන එක. ඒ ටික තමයි මේකේ තියෙන වෙනස් ඒවා. The testing hypothesis questions. It was the next one is 2.8 chi-square distribution. 2.8 chi-square distribution. 2.8 තියෙනවද note එක? Do you have it? 2.8 chi-square. Note එක තියනවාද? Do you have the note? Note එක තියනවාද ඔයගොල්ලෝ ගාව? 2.8 chi-square. Chi-square distribution note එක තියනවාද? note එක තියනවාද නැද්ද කියලා විතරක් කියන්න මට.
තියෙනවා madam.
ඈ?
තියෙනවා.
තියනවා නේද? හරි. අපි ඒකත් පටන් ගමු නේද? chi-square. Chi-square distribution. මේකත් සම්පූර්ණ ගාණක් 20 marks question. Chi-square distribution is another 20 marks question. ඒක note එක පොඩ්ඩක් හරව ගන්න මම විනාඩියක් දෙන්න. chi-square අපි පටන් ගමු අද chi-square distribution chi-square chi-square distribution 2.8 chi-square distribution. Once a sample drawn from a normal population with a known variance, sampling distribution of sample means are normally distributed. අපි සාමාන්‍යයෙන් අපි ගත්තේ මෙච්චර වෙලා. So then we have done some hypothesis testing questions. So then all sampling distributions. So there are a lot of sampling distributions we study. The most of them follows a normal distribution. Sampling distribution of sample means, sampling distribution of sample proportions, difference between two means and difference between two proportions. So then very few sampling distributions. So follows a T distribution. So in case of the small samples from a normal population with unknown variance, once we draw a small sample, so then sampling distribution of sample means follows a T distribution. So anyhow, up to that, all sampling distributions we study. The sampling distributions figure. So either normal distribution or T distribution. Very area normal distribution. A lot of things are normal distributions, and so then very few sampling distributions, they are T distributions. Sample means, sample proportions, difference between two sample means and difference between two sample proportions. මෙන්න මේවා තමයි අපේ normal distribution or T distribution. But equal size samples drawn from a normal population with known variance, sampling distribution of sample variances does not distributed normally. එතකොට sample mean එක sample proportion එක normal distribution එකක් සමහර වෙලාවට T distribution එකක් වුණාට sampling distribution of sample variances are they are not normally distributed. ඒක normal distribution එකක් නෙමෙයි. Sampling distribution of sample variances follows a distribution which is known as chi-square distribution. එතකොට sampling distribution of sample variances, so that the distribution follows a chi-square distribution. මෙන්න මේක අපි distribution එකට අපි කියනවා chi-square distribution කියලා. Chi-square distribution. Characteristics of chi-square distribution. There are no negative values in chi-square distribution. So normal distribution and T distribution both has negative values. It is goes up to from minus infinity up to plus infinity. So then both distributions symmetrical around zero. So then it starts from minus infinity and goes up to plus infinity. Symmetrical distributions. Normal distribution ekai T distribution ekai dekama symmetrical around mean zero, and so then values are from minus infinity up to plus infinity. But chi-square distribution, so there is no negative values. It is only from 0 to plus infinity. Chi-square distribution, there are no negative values, goes up to plus infinity. So then there are no negative values in chi-square. So it involves square deviations, and hence it is always a value between 0 and plus infinity. Variance එක කියන එක හැම වෙලේම වර්ගයක්. එතකොට එක කොහොමද ඍණ වෙන්නේ නැහැ. ඒත් ඒක 0 up to plus infinity. The second property, chi-square distribution is positively scaled distribution. So this is not a symmetrical distribution. මේක සමමිතික එකක් නෙමෙයි. Chi-square distribution is the positive scaled distribution. Non-symmetrical, asamamithiga vyaptiya. So this is a non-symmetrical. So in non-symmetrical, the positively scaled nature, again when we positively scaled one, chi-square distribution. Start with 0, 0. Positively scaled plus infinity. Chi-square distribution is positively scaled. When number of degrees of freedom increases, chi-square distribution approach to a symmetrical one. Now this one is once again depending on degree of freedom, same as T distribution. So there are some set of T distributions. T distributions අපිට කුලකයක් තියෙනවා මේ depending on the degree of freedom. Degree of freedom එක මත රඳා පවතින T distributions වගේම මේකේ තියෙනවා. So there are some set of chi-square distributions. Make a degree of freedom is not n minus 1, a different method. මේකේ අපි degree of freedom එක ගන්න වෙන විදිහකට. So anyhow, හැබැයි when number of degree of freedom is increases, ඒක වැඩි වෙන්න so then it goes to a symmetrical nature. ඒක සමමිතික බවට පත් වෙනවා. So then same as T distribution, chi-square is also a family of curves. A degree of freedom එකේ ඇති වෙනස් වෙන විදියට. So there are some set of curves. There is a particular distribution for each degrees of freedom. T distribution එක වගේමයි මේක. So then the chi-square table value. Chi-square distribution එක අවුගොල්ලෝ ගාව තියෙනවා මට ඒක කියන්න නම් අමතක වුණා. Chi-square table value. So then අපි chi-square ගණන් හදනකොට table value එක ගමු. Using relevant table for chi-square distribution, the area of the right-hand side tail of the curve is derived with the reference to degrees of freedom and alpha if the value is given. So the chi-square එකේ now this is our alpha. මේ area එක සහ t එකේ වගේමයි. Now this is the value, the area of the right tail. Say that this is alpha. මේ alpha එකයි degree of freedom එකයි ඒක තමයි අපිට දෙන්නේ degree of freedom and alpha. Alpha is 0.05, 0.01 significant zero. Now this shaded area is rejection region. Within a rejection region. Rejection region, and then there are a set of values depending on degree of freedom. Degree of freedom එකත් එක්ක වෙනස් වෙන අගයන් ටිකක් තියෙනවා. So now this degree of freedom is not n minus 1. මේක වෙනස් විදිහකට තමයි අපි ගන්න degree of freedom. So anyhow, depending on value and alpha. Alpha is the shaded area. Now this is your critical region. මේ තමයි critical value. Alpha value 0.05 නම් එතන එක තියෙන value එක තමයි critical value. Then there are three types of chi-square tests. Chi-square test වර්ග තුනක් තියෙනවා. Chi-square test තුනක් තියෙනවා. So then you have only one test with you. ඔයගොල්ලන්ට තියෙන්නේ මේකෙන් එකයි. පළවෙනි එක තමයි different types of chi-square test. Chi-square test is the test of hypothesis for population variance. එතකොට අපි එක chi-square test එකක් පාවිච්චි කරනවා to calculate the population variance. So they say that the population variance is this much. කවුරු හරි කියනවා population mean එක වගේ variance එක මේ ගන්න. ඒක check කරනවා by based on sample data. So what is your chi-square value? එතකොට ඒකෙදි අපි පාවිච්චි කරන so this is a Greek letter. මේ chi-square කියන එක කියන්නේ මේක. x අකුර වගේ නෙමෙයි එකක් මෙහෙම ලියලා chi-square. Chi-square for variances n minus 1 is square divided by sigma square. So then no worries about that. This part is not in your syllabus. Make a day. So then chi-square test for variances. Variance එක check කරන chi-square test එක නෙමෙයි කියන්නේ. Second one, chi-square test of goodness of fit for probability distribution. මේක තමයි දෙවැනි එක. So then they have given some information. අපි හිතමු. So then they have given like last month the number of accidents in a particular junction. Automobile accidents ගන්න පොඩි විස්තරයක් දීලා තියෙනවා. 0 accidents with for last 30 days. There are 15 days. 1 accident with 3 days. 2 accidents with 4 days. Like that. මෙන්න මේ වගේ දීලා අහනවා are they follows the Poisson distribution. And there are standard distributions available, fixed about the Poisson model, binomial model or normal distribution. That is called chi-square test of goodness of fit. So then second test is not in our syllabus. Third one, chi-square test for independency. So what is this independency? Now here we are going to check whether, so any variable, pair of variables are there. What do you call that? TV program. There is one TV program. So then, what do you call the preference of that TV program in age category? So ඒකට කැමතියක් නැති බව. අපි ගත්තොත් එහෙම අවුරුදු 25ට අඩු 25 ඉඳලා 50 50ට වැඩි. මේ එක එක age category වල අයකින් අපි so then we have collect data and see whether the age category and preference of TV program is independent or not. Independence test. මෙන්න මේක තමයි අපිට තියෙන chi-square එක. So then for both second and third test, our chi-square value is equal sigma O minus E square over E. මේ O කියලා කියන observed frequencies, මේක අපිට observed frequencies කියන අර මම කිව්වා වගේ table එකක දෙනවා age category. Let's say 0 to 25. වයස 25ට අඩු 25 ඉඳලා 50ට 50 ඉඳලා 50ට වැඩි. ඒතකොට මේක එකයිකින් අපි අරගෙන 25ට අඩු කට්ටියකින් අපි ගන්නවා 10 දෙනෙක්. එතකොට so then 8 likes to the TV program dislike. ඊළඟට අපි ගන්නවා ඊළඟ කැටගරි එකේ අපි ගමු තව 50ක් ගන්නවා. එතකොට මේකෙන් 30ක් කැමති TV program එකට 20ක් කැමති නැහැ. ඒ වගේ that is these are the observed frequencies and E is the expected frequency to be calculated. මෙන්න මේ ටික අරගෙන අපි බලනවා so then is there any the two variables are dependent or independent. මේ variables දෙක අපිට table එකක් විදිහට දෙනවා. age category එකයි TV program එකට තියෙන කැමැත්තයි. එතකොට මේ දෙක එතකොට TV program එකට තියෙන කැමැත්ත so then depending on the age category. මෙන්න මේක තමයි අපි දැන් හොයන්න යන්නේ chi-square test for independency. ඒක තමයි අපිට තියෙන්නේ. මම එමන ඊළඟ ක්ලාස් එකේ මේක කරන්නම්. මොකද ඕගොල්ලෝ දැන් ළමයි දෙන්නින් පත් නැද්ද ඔයගොල්ලෝ පන්ති. මේ ඊළඟ දවසේ මම මේක කරන්නම්. මේ ඊළඟට මම ඕගොල්ලන්ගෙන් අහන්න කැමතියි මම මේ ක්ලාස් එක දාන දවස් වලට ඕගොල්ලන්ට වෙන පන්ති තියනවද නැත්නම් වෙන ප්‍රශ්නයක්ද ඇයි එන්නේ නැත්තේ පන්තියට? ඕගොල්ලන්ට වෙන මොනවා හරි ක්ලාස් තියනවද එදාට?
නෑ මැඩම්.
එහෙම නැති දවස් මොනවද තියෙන්නේ?
මැඩම්ගේ දවස් වලට පුළුවන් අපිට.
මොකද්ද?
මැඩම්ගේ දවස් වලට පුළුවන් මැඩම් අපිට.
පුළුවන්.
ඔව්.
නෑ දැන් ඊයේ හිටි පන්තියේ 10ක් හිටියේ අද ඉන්නේ 5යි ඒකයි මං ඇහුවේ. ඇයි කියලා. මොනවා හරි වෙන පන්තියක් තියනවද නැත්නම් මං උගන්වන එක තේරෙන්නේ නැද්ද? මොකක් හරි ප්‍රශ්නයක් තියනවද කියලා මං ඇහුවේ.
මැඩම් මේ දවස්වල වහිනවනේ මමත් ලේට් වෙලා ජොයින් උනේ ගොරවනවා හොඳටම.
ඔව් එහෙම එකක නෑ ඒ වගේ පොඩි අවුලක් නම් තියෙනවා තමයි නේද? වැස්සයි ගොරවනවයි දැන් අර ඉස්සෙල්ලා කියපු එකක්වත් මට ඇහුන්නේ නෑ. හරි එහෙමනම් ආයි කවදද ක්ලාස් එක දාන්නේ? Thursday?
කමක් නෑ මැඩම්.
එහෙනම් මම බ්‍රහස්පතින්ද දානවා. දාලා මම මේක ඉවර කරනවා chi-square එක. මේක ලකුණු 20ක ප්‍රශ්නයක් chi-square test එක. chi-square distribution කියලා එකක් තියෙනවා. ඒකත් අරගෙන එන්න ක්ලාස් එකට. හරිද? chi-square distribution කියලා එකක් තියෙනවා. ඒ table එකත් අරගෙන එන්න ක්ලාස් එකට. එහෙනම් මම ආයි ක්ලාස් එක Thursday දානවා.
හරි මැඩම්.
Thursday, Friday, Saturday. එතකොට අපිට මම හිතන්නේ මේකේ papers ටිකක් අරගෙන මේ ඉවර කරගන්න පුළුවන් වෙයි. ඊළඟ පන්තියේ තියෙන්නේ Thursday. හරිද? හරි එහෙනම් මම දැන් නවත්තනවා පන්තිය.
හරි මැඩම්. thank you. good night.